next. Okay. So we'll move to the next part. Okay. Next part, what are we going to see? When the object is kept at F. Okay, now we are going to see when the object is kept at F. Okay, what is happening to the object when it is kept at F? So these are like easy things when you understand the concept. Okay, I hope we can finish the lens part also today. So we when the object is kept at F. Here the object is kept at F. Object is at F. Okay, object is kept at F. So this is the diagram we are going to draw. This is the principal axis and we have F and then 2F, again F and then 2F. Okay, so now we'll keep the object at F. Okay, object will be kept at F. Okay, object is kept at F. So what's the first rule we are going to apply? When the light ray goes parallel to the principal axis, when the light ray goes parallel to the principal axis, it will be sent through the focal point. And what's the second rule? When the light ray goes through the what? What is this? When the light ray goes through the optical center, it will be continuing to move through the optical center. So when we draw such a light ray, what happens is these light rays will not be like joined. Okay, they will not coincide each other at any point. Okay, they will be continuing to move parallel to each other. So we say that when an object is kept at F, image will be formed. Image will be formed at infinity. Image will be formed at where? Infinity. We don't know where the image is formed. And the image will be what? It will be magnified. It would be magnified. Okay, the image would be magnified. And also the image will be formed on this side. No, so see here the light rays are going towards the image. Therefore, what's happening? Here the image would be real. Image is real. And then what is the other last thing? We can say that the image is also inverted. The image is also inverted. So these are the main characteristics of the image formed when the object is kept at which position? Kept at the focal point. Okay, these are the characters of the image when the object is kept at the focal point. Okay, now we are moving for the last condition, last thing. What's the last thing? We are going to keep the image between the lens and the focal point. We are going to keep the image between what and what? Between the lens and the focal point. Between lens and F. Between the lens and F, we are going to keep the image. Okay, between the lens and F, we are going to keep the image. Let's see what happens here. We have the lens and then the principal axis. We are marking the position F and then 2F. Here also we are marking F and then 2F. And image is kept where? Image is kept between F and 2 lens. Okay, image is kept between the lens and the F point. Okay, let's draw the ray diagram. When the light ray is sent parallel to the principal axis, it will be sent through what? Sent through the F point. And when the light ray is sent through this one, what is the optical center, it will be continuing as a straight line. Now we have to extend these two lines because in this direction they won't meet. So now we are going to extend these two lines. See here. This is how we are going to extend these two lines. Okay. This is how we are going to extend. And now we will get a point at which these 2 points are meeting. So this would be the image. This would be the image and this is the object. So see here, the light rays are going what? Away from the image. Here the light rays are going away from the image. Since it goes away from the image, we say that this image is virtual. This image is what? This image is virtual. Give me a second. Okay, so this image is what? This image is virtual. And also, this image is larger than the object. No, this image is larger than the object. Therefore, we call that this image is also a magnified image. This is a magnified image since it's larger than the object. And the image is formed what inside the lens, right? Image is formed in front of the object. Image is formed in front of the object. And image is also what? Upright. The image is also upright. Formed in front of the lens. Okay, formed what? In front of the lens. In front of the lens. And also image is upright. So these are the characteristics of the images when the object is kept between lens and focal point. Is it clear?
Yes, teacher.
Okay. Okay, now we have only the concave lens. After that, this whole unit is finished. Okay, this whole unit will be component. I want you to put this chart. Okay, last class also we did the same chart. I want you all to put the same chart. Uh, this I'll send you the chart again. Okay, I'll send the chart again. The same thing we did for concave mirror. I want you all to put the same chart for convex lens also. Because from that chart you will understand that concave mirror, okay? Concave mirror and convex lens. Concave mirror and convex lens are behaving the same way. Okay, convex lens and concave mirror are behaving the same way. Okay, so you all have to complete that chart as well. Now we'll move for the concave lens. We'll move for what? Concave lens. Okay, we'll move for the concave lens. We have the concave lens. See here, this is the concave lens. This concave lens will also have the same thing. What is the straight line? We call this straight line as the principal axis. This is the principal axis. And then we are putting a center trace line. And this point is the optical center. This point is the optical center. Okay. After that, we can have what? Focal point and then center of curvature on either sides of the lens. We are having what? Focal point and center of curvature. So these are the things you all have to know when you are drawing the concave lens, okay, in the ray diagrams. So again, this concave lens have two main rules. Okay, concave lens have what? Two main rules are there. Okay, so we are going to see, so three main rules are there. We are going to like easily see the, yeah, we'll see the three main rules. Okay. So, sorry, yeah, there are three main rules. So the first rule states when the parallel light ray comes parallel to the principal axis. Here, this is a diverging lens. No, concave lens is what? It is a diverging lens. So when the light ray goes parallel to the principal axis, when the light rays goes parallel to the principal axis, it will be what? It will be bent, go away from, okay, it will be bent and go away from the lens. Okay, and if it was extended, it will seems like that it goes through what? The focal point. Okay, so when light ray comes parallel to the principal axis, it will be bent and go away from the principal axis. It will be bent and it would be go away from the principal axis. And if that line was extended, what's happening? It would be seen like what? It is going through the focal point. So you all have to write under this as what? when the light ray comes parallel to the principal axis. This is the first rule, okay? When the light rays comes parallel to the principal axis, it will be bent and go away. It will be bent and go away. When it is extended, when it is extended, when it is extended, it will look like, it will look like as it is going through the focus, as it is going through the focus. So this is the first rule. And now we'll move for the second rule. See here, we have the convex lens. Sorry, concave lens. Now the second rule states the opposite one. When a light ray seems like going through the focus, okay? When a light ray seems like going through the focus, okay? When a light ray seems like going through the focus. It's not going through the focus, but it seems like going through the focus. Okay, it will be sent parallel to the principal axis. It will be sent parallel to the principal axis. So this is the second rule. When a light ray seems like going through the focus, it will be bent and sent through parallel to the principal axis. Okay, so this is the second rule. So right under this, when a light ray seems like, when a light ray seems like going through the focal point, when a light ray seems like going through the focal point, it will be sent, it will bend and sent, it will be bent and sent parallel to the principal axis. It will bend and sent parallel to the principal axis. So that's the second rule. Now we'll move for the third rule and the final rule. Okay, so this is the third rule. We have the concave lens and then we have the principal axis. And here is the optical center. So the third rule states the same thing. When a light ray goes through the optical center, it will be continuing and forming the straight line. It will continue to form a straight line. So when a light ray goes through the optical center, it will go through it continuously in a straight line. Right under this, when a light ray goes through the optical center. When a light ray goes through the optical center. Okay. It will continue to move in a straight line. It will continue to move in a straight line. I hope we can finish the whole lesson today itself. Okay, we have only one more part to do. Okay. So those are the three main rules. So by using these three rules, we are going to draw the images for the concave mirror lens. Okay, we are going to draw the images for concave lens. So let's see how we can draw the images for concave lens. This is the concave lens. And we have what? The principal axis. And wherever we keep the object, okay, wherever we keep the object, the image will be formed at the same position. Image will have the same character, okay. So therefore, we don't care where we keep the object, okay, wherever we keep the object. This is similar to what? Convex mirror. This is exactly similar to the convex mirror, okay. So now we keep this object, okay, this is the object. Okay, see what are we going to do? When the light ray goes parallel to the principal axis. I have to say this rule again and again, okay? It will be sent what? It will be sent away. When it is extended, it will seems like going through what? The focus. It will seems like going through the focus. When light ray goes through the optical center, okay, when the light ray goes through the what? Optical center. When the light ray goes through the optical center, it will continue to move through the optical center. So this is the second rule. Okay, this is the second rule. So now we can find a what common point, right, at which the image is formed. So this is the place where the image is formed. This is the image. Okay, this will be the image. See here. Now what has happened to the image? Is the size has reduced or increased? The image size is diminished or magnified? The size. What has happened to the size?
Diminished.
Very good. The image size has diminished. Okay, image size is diminished. And then, is it upright or virtual? Sorry, upright or inverted? The image is
Upright.
very good. The image is upright. Okay. And then, is it virtual or real? The light rays are going away from the image or going towards the image?
Uh, Virtual.
Very good. It's virtual because the light rays are going away from the image. Okay, therefore it's a virtual image. And then what happens to the what is the location? The image is formed between the focus point and the optical or else lens. Okay, so image is formed between what? Formed between focal point and lens. Image is formed between the focal point and lens. So these are the four main characters of the image formed using a concave lens. Is it clear? So wherever we keep the object, this is the image. Okay, this is the exact location and exact characters of the image. Is it clear?
Yes, teacher.
Okay, so you all have to remember concave lens. Okay, concave lens. We have what? Concave lens. No, concave lens and concave lens and convex mirror. Okay, concave lens and convex mirror will always behave in a same manner. Concave lens and convex mirror are behaving in a same manner. The exact opposite happens. Convex mirror, convex lens and concave mirror. And the concave mirror will always behave in the same way. So we proved this through the formation of images. Okay, so these are you have to highlight this part. Okay, put a red color box around this and keep it in your memory. So these are the stuffs which are in this whole unit. Okay, so we are done with this unit. There is a small point I'll say. Have you all seen this microscope or else hand lens? Hand lens. We say that Bhuta Kannadi. Have you all seen this? The hand lens. In hand lens and also in the microscope. Okay, in hand lens and microscope, we are using the convex lens. Okay, in hand lens and microscope. Okay, we are using microscope. Okay, so these are the two instruments which mainly uses the convex lens. So that's it for the whole unit, and we are done with the unit 5. Okay, and we are going with so I thought of keeping a paper, okay, giving you all a paper from the first 5 units. Is it okay? Like we today on Friday, I'll be giving you all a paper. Okay, I'll be giving you all a paper from the first 5 units and also from the digestive system. Okay, because we are done with the digestive system now. So from the first 5 units and digestive system, I'll be giving you all a paper and you all have to time it and do it no copy. Okay, no copies. You all have to do it by your own self. Okay, so on Friday we are at the class time we'll be doing this paper, and from next Wednesday we are starting unit 7. Okay, from next Wednesday we'll be starting unit 7, inshallah. Okay, so you have any doubts?
No, teacher.
No, teacher. No, no. Okay. So up to this, you're clear, right? Okay.
Yeah.